Okay. It's like a boutonniere. It's like I'm getting married again. Yeah, 35 years later. 35 and a half. Man, time flies. Um, See, the only bad part about this is I have to be careful what I say, so I'm not nearly as funny when I have to like watch what I'm saying as I actually actively have to watch what I'm saying. So yeah, that's what everybody says. I don't trust you further than I can throw him. I don't even think I can pick him up. All right. I don't know. Jaden, I might get a couple of feet out of him, but Steve over there, I'm not even. All right, so pretty hard name. Yeah, really, more like a shot put or something than a. Right. Okay. For 2 seconds out of the 8 weeks. Well, I was serious yesterday at a time or two. I'm sure you guys can tell. Okay. For probably the only one of the few. Okay. We're just gonna start, and I'm gonna be very, very honest, or very, very. Does anyone not know how to measure 220 volts AC? There are people here that they just don't know how to do it. They've never known how to do it. Okay, fine. It's just I always ask this early because if you don't, you need to know. Okay, so I had a gentleman in class. He wasn't in my class. He was in the other class, but we got to this point in class, and he asked if we were measuring in ocean waves or railroad tracks. So there's that, right? And then you have the omega signs, right? And you have omega signs, railroad tracks, and ocean waves. We are measuring in ocean waves, okay? Because ocean waves is AC voltage and railroad tracks is DC voltage. But when you look at it, it really, that's like you ever seen it on Instagram? Some young person looked at the vent on the dashboard and couldn't figure out why it was bacon or email. It's like once you see it that way, you're like, bacon and email, right? Then there's this like the other one where the lady doesn't understand why there's a guy sitting on the toilet in her dashboard, and it's because it's -4 degrees, -4 degrees Fahrenheit or something like that. So it has the minus and the four, and then it looks like a guy. It's just people just see things differently. So it's it just happens. Okay, so I don't know how many of you gentlemen have electric dryers. So older electric dryers, like in older houses, an electric dryer will only have three conduits. There are three. It's one conduit. Three. Huh? Three legs, three leads. Three. We'll go with leads. So an older uh, electric dryer will have three leads. A newer electric dryer will have four leads. Okay. Um, on 200 and so let's start out with 110 volts. 110 volts has a hot leg, which is black, and it has a white leg, which is usually what we call neutral, and then the round leg is always green for ground. Okay. The old saying, black to brass saves your. Okay. All right. So that's if you're ever wiring up a plug in your home. The white wire goes to the silver screw, and the black wire will always go to the copper or the brass screw. That's the saying. Otherwise, you're going to wire the thing backwards and everything. And most things nowadays have an inverter, and it'll be fine. But sometimes it'll cause the lights to blink, and it'll do some really weird stuff. So 110 volts. AC stands for alternating current, which means the current literally moves back and forth. As the current is moving back, because the current has to come back to the power station. So the current is moving back and forth. Not only is the current moving back and forth, but the current is now going through the light or going through the motor or something. So some of the current that gets sent out doesn't actually come back because it's being used for power. So then more power, more current has to come back on this side, and it's sort of like cross-country skiing. The guy's always moving his arms. Okay. That is AC current. DC current, DC current you have, because Ford wiring is so weird. It's always got tracers. We're going to use Chevrolet wiring because it's fine. So if you have DC current in a Chevrolet, usually the red or the orange is positive voltage, and then the black. If you could get that from Mr. Chuck right there for me, just drop it off to any one of these guys. Mr. Chuck, thank you so much, sir. DC voltage goes either red or orange is usually positive and black is usually negative. Okay, now we can get into the argument of usually they'll tell you that it goes out on the positive and comes back on the negative, and then there's the people in the group that say it actually comes out of the negative and returns on the positive, but everything is always hooked up to negative and we always fuse the positive side even though the amperage is going backwards of the way most people think it's going. Most people think the amperage is on the hot side and going to the negative, and it's, I guess we didn't know that when we first made cars or something, because it's always, and we still haven't fixed it, right? We still don't, we always, the ground is always universal. We have ground spots on the car and everything's on the hot side. I don't get it, whatever. AC current, back to AC current. So we're using a lot of AC current. We're either using 110 volts or 200, and usually I say 110, 240. So again, anything with, so ACE 110 volts has one hot leg, one neutral leg, and one ground. That way, in case you're standing in a puddle while you're soaking wet and you touch something, you don't get electrocuted because you're supposed to be grounded, and then you're not supposed to get hurt. Or if you're touching two pieces of the metal, the two different pieces of the metal aren't supposed to, like, you don't make the ground between the two pieces of metal. When we're putting together one of these tire changers over here, like you guys saw that tire changer yesterday, this tire changer came in a box that was about yay big by yay big by yay big, and this top piece here doesn't come on the unit. In one of the studs, there's going to be a serrated washer that you put the tank on, you put the serrated washer on the stud, then the flat washer, and then the nut. And the serrated washer, as you tighten it up, the serrated washer cuts through the powder coating so that the tank is now grounded to the base, so that you don't become that ground if you happen to touch both pieces at the same time. You're only getting hit by like 40 volts. It's not that bad. It's not that bad. 40 volts is very low amperage. It's the amps that kills everybody, right? You can get killed on a half a volt DC as long as you have like 10,000 amps, right? It's always the amps that kills you. It's never the voltage. Still, it's unpleasant. It's about 40 volts. No one likes it. So there's always that one star washer that you always make sure you put on. Okay, so 110. We still need a return leg on 110 because you can't send something out if it has to return somewhere. 220 on modern day appliances. You have two hot legs. It's usually a black and a red are your hot legs, and the 220 does this. Usually the white leg is the neutral. In case something happens to one of the hot legs, you still have a neutral to get the electricity back to where the electricity comes from. And then the fourth leg, which is usually has the little tang on it, is the ground. Okay, and the ground again is the ground. It keeps everything grounded so that you don't become the ground and then the electricity doesn't flow through you. Okay, that's in the United States. Evidently, we do stuff weird. The whole entire rest of the world only uses 3 wires in their conduit. Okay, so you have 2 hots and a ground, because technically you don't need a neutral as long as you have the ground, at least the way the Europeans do it. So since we get tire changers in from Italy, we adopted that all of our power cords are going, because the United States is one country and the whole rest of the world uses the other wiring system. So we have adopted the other wiring system. The other wiring system is your power is light blue and tan, and then your ground is yellow with a green stripe. Okay, so if you break open any of our power cords, even on a 110 aligner, if you cut open one of our factory power cords for an aligner, you're going to have a light blue, a tan, and a yellow with a green stripe. So you have to get used to seeing wires that don't look right, because most people are either used to, again, either black and white or black and red one. The other reason why we adopted the European method is they only use 3 wires in their conduit, and guess what that allows us to do? We save money, right? Because we don't have to put that 4th conduit in it, okay? So again, that's how I can take a 110 volt extension cord and turn it into 220, because I have 2 hots and a ground. Most of the time I never even hook the ground up, because all you really need is 2 hots. long as you're not standing in a puddle of water. So don't stand in a puddle of water while you're putting together equipment, okay? Because technically you just need 2 hots, which is why you can take the 110, okay? All right, so for us, I don't know how many people were around Jess when he took this. So this is called, this is a receptacle, right? We have a plug and a receptacle, okay? Every time when he took this plug apart, the ground here always has a green screw. All right, you had 2 brass screws because they're both hot, and you had a green screw. The green screw is always going to be your ground. The green screw is always going to have that funky little flipper. The flipper usually flips in towards the circle on 220. The flipper usually flips out if you're doing 110 volts. Like if you have one of these that's 125 volts, 30 amps, and it's a twist lock plug, the little doohickey will flip out. And then that'll dictate if it's a 110 or a 220 plug, okay? So if you notice, I have 2 regular straight terminals, and then I have this one over here, looks like an L. Okay, the L is always going to be my ground. At this point, since it's only 220 single phase, it doesn't matter if I do blue and tan or blue and tan, because it's 220 and it's alternating current. Okay, as long as you put the green on the funky leg, okay, and you make sure it's got the green screw, technically it's yellow with a green stripe, everything will be fine. Okay? All right, so in order to measure 220, you measure one of the legs to ground, and you should get around 110, 115, 108, whatever you're going to get. You measure the second leg to ground, and you get an additional 110, 115. Then you measure the 2 legs together, and that's where you get either 220, 218, 208, or whatever you're going to get. Normally, you can't just add the 2 110s together and it comes up with the 220 voltage. That's the magic of electricity. Go find Nikola Tesla and ask him why it doesn't add up, because it doesn't add up. Everyone knows it doesn't add up, and everyone's fine with it. So it's just one of those things, okay? So it's just one of those things. Again, so we have to measure individual legs, okay? When you guys in a breaker box, I don't know how many of you guys actually seen the actual breaker box, but there's a bus bar on the left and a bus bar on the right. These bus bars are technically 180 degrees out of phase. So like think of an ocean wave. Okay, it goes like this. When the one ocean wave is all the way up, the other leg of power, the other ocean leg is all the way down. And then they come together and then they separate again. So I have 220 way out here. When they come together, I technically have 0. Right? And then they split back apart again, and I have 220 because that's like 100. You can't really say, you can't use positive and negative, but it's like 180 degrees positive and 180 degrees negative, and they add up to 220. The math doesn't work that way. It's just that's how the phasing goes, okay? That's why in a 220 motor on a single phase, you have a run capacitor. The run capacitor, after these 2 lines start to get too close to each other and they don't have enough voltage to keep the motor or the engine turning, that capacitor has stored energy, and it bridges on both sides. It bridges so that the two legs don't never come actually and touch each other. The 2 legs hit the capacitor, move over, and then the 2 legs split apart again. That's when it gets a little crazier. I'll have to put it up on the board, but on 3-phase power, because you have a third leg of power that's offset by about 120 degrees, that third leg, you never hit 0, because 2 of your legs are always far enough away from 0 that the machine continues to run. That's why you don't need an actual run capacitor, okay? We cheat. On 220 single phase, we cheat and everything comes in, but then the motor would have to start and stop and start and stop and start. So we put capacitors in it, okay? 3-phase, so okay, the other thing, think of a clock, and you have a clock, and let's just say it's 110 volts. 110 volts, the power comes in at 12 o'clock. So I'm gonna need, let's do this for easy math. I'm gonna need 12 amps to go from 12, I have to go all the way back around the clock again to 12 o'clock before I get more power. So that's why 110 volts will use more amps. If I have 220 volts and it's single phase, you know what bothers me about that? It's technically two phases. And we never say 220 two phase. It is still called single phase. I lose sleep over that sometimes. It's like it should be 220 two phase, but we call it single phase. Again, blame Nikola Tesla, I suppose. I don't know. I love that guy. That guy's crazy, but he was a genius at the same time. 220 single phase, you have electrical input at 12 and electrical input at 6. So 220 single phase, if I had 12 amps to go all the way around, now I only need 6 amps because the 12 has to get me to 6, and then I get fresh power at 6, and then 6 takes me back up to 12. So 220 single phase, I only need 6 amps of power. If I have 3 phases of power, I do 12, 4, and 8. So now I get power at 12, I get power at 4, I get power at 8, and it brings me back around. Now I only need 4 amps, right? Because 12 divided by 3 is 4. So if I have a 3-phase motor, I'm running less amps because I have to go less before I get more power. That's why a 3-phase motor will run quieter, run cooler, and run more efficient because it's actually using less amps. It's still using the same amount of volts, but it's using less amps. Okay. On a 3-phase motor, you'll actually have 4 prongs. One is still ground, and then the other 3 prongs are power. So you would do the same thing. You would take 1 to ground, 2 to ground, 3 to ground. Then it gets a little funky because you have to do 1 to 2, and then you have to do 1 to 3, and then you have to do 3 to 2 because you have to check all 3 legs of power. Now we're going to ohm out a 3-leg power motor. We're going to ohm it, and you still have to do the same thing. You're going to ohm 1 to 2 and check the ohms. You're going to ohm 1 to 3 and check the ohms. And then you're going to check 2 to 3 to check the ohms because we have to get the ohms on all 3 legs. Okay? So the beauty of Hunter tire changers, except for the 645, every other tire changer we use, if it's a 110 volt plug, it's a 110 volt plug. If it's a 220 plug, every other tire changer we use uses 220 single phase because, again, we get to save money by only having 3 con instead of 4. What happens in the inverter is the inverter inverts it or invents a 3rd leg of power. A lot of magic going on those boards because you just randomly make up a leg of power. Because if you want to have speed, the ACT, or if you want to have the pedal to where the pedal, like the pedal on this one here, if I push down a little, I go slow. If I push down a lot, I go fast. It's because you need 3 phases of power in order to speed up or slow down a motor. So that's why we take single phase, we invert it into 3 phase so that we can have, they say unlimited, but it's got to be limited at some point because you got to start in the beginning. But they say you have unlimited speeds, right? Yeah, between here and here, you have 0 and you have 100, and you can do whatever you want in between. Okay? So, come on up. Now, when you're touching these things, always make sure you touch the plastic and don't touch the tips while you're trying to measure stuff because you will electrocute yourself. So that's why they got the little speed humps here. Keeps your fingers from touching touchy parts. So go ahead and put this on Ocean Waves for me. Once you say it, you can't not say it. It's just too funny. It's just Ocean Waves. All right, so you can go ahead and put that down. Okay, it's A for auto ranging, AC. Okay, so you're going to take the black guy there, and you're going to stick them in the. Yeah, you're fine. Okay, make sure you should be able to feel the brass underneath this. Just stick the black prong in and wiggle it left to right until you can actually feel it. There you go. Okay, so you're going to measure here to there, and you should get. Nope, keep trying. You want to hold this too, because sometimes you have to hold this while you're doing that. All right. Okay. All right. I am plugged into the wall. This is a good cord. Nope. You're on amps. You're on ocean waves. You're on alternate ocean waves. We want to be on regular ocean waves. So V for volts. Volt waves, not amp wave. Amp waves you have to measure differently. That's why you have to have that clamp, that little black thing with the coiling. So you want volt waves, not amp waves. Okay. Thank goodness we didn't blow up the motor. Okay. So all right, so we got 144 from one leg to ground. Now you're going to keep the ground and you're going to go to the other leg. Okay, and from the other leg to ground, well, he only has 12, so I'm going to say that's not right. It's probably that guy there. Okay, nope.
Less, what the hell?
Well, you're good at it. There you go. All right, we have 144 on the other leg. So we have two. So on our oscillating waves, right? So everything's from zero. Right? We have 144 going up. We have 144 going down. Now you're going to measure across the 2 points. So you're going to do just the 2 hots. Okay. So 144, 144 is 288. He's not going to get 288. He's going to get about 253. 242.8. Okay, so the people who know electricity are going to be like, dang, that's hot. Because that should really only be somewhere around 212, 218. Anything above 230, and most electricians are like, something's wrong. Okay, so all right, you can let that go. So this wall only hits about 242 to 245 volts. This wall over here is like 218. That wall over there is normal. It's like 213. I don't know why this wall is special, but this wall is special. You can sit back down. You've been a great contestant. So, believe it or not, 242 volts, we don't like that. It's actually kind of surprising that this machine works on 242 volts. Usually our range is like 198 to about 238. Anything over 238 volts, the AC circuits and all the stuff inside the tire changer, especially if it's a balancer. If I had a balancer plugged into this wall, that balancer would not work properly. There's actually too much voltage for a balancer at 243 volts. There is a company out there, it's called Buck Booster, Buckbooster, Buck Booster. It is a standalone mini transformer. It allows you to buck boost up and down. So if you do run into a place that has like 245 volts, you're probably going to get some weird thing like an error code 4 on a balancer. I have to tell this to the guy in the Dominican Republic. You have too much voltage, and when the AC turns it into DC, it's just too high because you start out way out here, so the DC is way up here, and then your circuit boards don't work right. You buy a buck booster, and you plug the buck booster into the wall, and then you can tell the buck booster, do you want to boost it up or do you want to boost it down? So I had to buy one time, and I had a buck boost it down to like 215 because this guy was way out in the middle of nowhere. He was running like 253, and it was hot. That dude was hot. So I told it to boost it down. There's certain levels there's certain levels on the output. I boosted it down to about 215, and then he never had another problem out of his balancer. You don't even wire it in. It just comes with a plug, and then there's plug-ins in the front of it, either 220 single phase or 223 phase. It's just you just plug things in, plug and go. Yeah, it wasn't gigantically expensive. This was pre-COVID though, so it was only $500 or $600 pre-COVID, which means it's probably $2,000 now. Is it still? Okay, so it's still the same price. Okay. So for some reason, Buck Booster's not paying tariffs, and then the galactic back order hasn't affected Buck Booster for some reason. Or it's on since 2020. Yeah, we just said yeah. So again, you may run into that. You also may run into, especially if you have very old wiring, if you have an old city. I had the city of Griffin. It was an old cotton mill city. They also filmed The Walking Dead there. So if you ever go to Griffin, Georgia, you can pick stuff out from The Walking Dead. But it was an old cotton town, and the infrastructure was from the 40s and the 50s. They probably still had knob and tube in most of their buildings. And every day about 3 o'clock, all the people would come home, and it was a poor section of, so they didn't have whole house ACs. They had window ACs, right? So the window ACs aren't nearly as efficient. So everyone turned on their ACs. The voltage would drop down below about 198 volts, and their balancer wouldn't spin anymore because it didn't have enough volts to run. Right? Yeah. That was an independent Goodyear store, and they never bought a buck booster. They weren't going to spend the money. I'm like, I don't know what I can do for you. Anyway, so 220. Okay. If you really want to get into the weeds, I guess since we're recording, 110, the plug-in in the wall there, that is technically an L515. L5 designates that it's 110 volts. 15 designates it's 15 amps. Because both of my plug-ins are like this. If you get a plug-in like this or a plug-in like this, it's an L520. Right, you can get an L520 or an L520 because it's still 110 volts, but it's 20 amp. Okay. Anytime you're dealing with 220 volts, it's an L6. It's either an L620 or an L630. Okay. The Maverick tire changer, the Revolution tire changer uses a 30 amp breaker. All of our other tire changers will use a 20 amp breaker. Our balancers will use a 20 amp breaker. So you're going to be doing a lot of L620s. Okay. What I didn't know for the longest time is the 20 actually designates in millimeters the diameter of this circle, which is, I know, right? So simple. And L630 is 30 millimeters in diameter, which is why you have to bend the pins to either plug a 20 into a 30 or a 30 into a 20, because the diameter of the pins are literally 10 millimeters apart from each other. Okay. It's like someone thought of it one day. It's super crazy. So this here is an L620. It's supposed to be 220 volts, obviously a little hotter. And again, the pins are in a 20 millimeter circle. Okay. The day I learned that, I had to sit down for a minute. I was like, my whole life's been a lie at that point. Okay. Okay. We do have the 645. The 645 that was in the corner that does the ag tires. That is our only three-phase piece of equipment. A million years ago, we had a three-phase balancer for Firestone because Firestone paid us enough money to make a three-phase balancer. And we said, thank you very much. And we took their money and we made a three-phase balancer. But those balancers, they're an old balancer. So the 645 is pulling 30 amps, but it's three-phase because of how much it's lifting up. The other thing with the 645 for you electricians, there's a switch on the side of it that actually changes how the motor is wired. And it goes from delta to sure. And one is low speed and one is high speed. But by changing the wiring or how the electric box is wired, we either have like low speed or high speed. I don't know which one delta is. I don't know if it's delta wire, delta. Okay, so
in that configuration, is that where instead of coming in at 140, one of them plugs in the manual?
Well, yeah. Basically, you're running it through 3 contacts.
Okay.
I'm guessing is what.
Yeah, there's lots of contacts down there. Yeah, so it's going to be very satisfying to him when he opens it up because everything is in a race and a channel and all the wires are in. They're zip tied and they're all the same color and it is on an OCD scale. That is, you just sit there and you go, because it is so nice.
Does it change the RPM motor by putting it in high speed?
Yes.
You're running like half-powered motor.
Yeah.
Is there one better than the other in terms of application?
Depends on how fast you want to hurt yourself. You can either hurt yourself in slow speed or you can hurt yourself at 2x speed. Personally, Personally, I always use the slow speed because if I have an 800-pound tire spinning faster that I'm trying to take off and put on, that just seems
I just
way.
didn't know if like the machine itself would rather see one or the other in terms of like accuracy. You know what I mean? I get that it's meant to be accurate regardless, but
Not really accurate. It's just it's either spinning. It's literally either spinning slower or spinning faster. And some people maybe if they're doing a smaller ag tire, they'll throw it up on the high RPM. But again, if I'm doing something that weighs 800 pounds, I really don't want it spinning that fast. But they all have it, and it's again, it's just a switch, simple switch on the side, and somehow that simple switch takes it and runs it either through this contact bank or that contact bank, and you get 2 speeds. It's quite something to see. So
YouTube video on it that like from our technicians that actually goes through. It's nice animated
okay.
video that really
I think I've watched it once, and then I was like, yeah, no, I'm good, and then I forgot. I was like, I don't need to know. I don't need
We've
it.
done every single water tank that's on like,
Okay. Yeah. So, yeah. So anyway, all right. So that is the basics of. Thank you. That's actually the router for the outside. So the problem is the high today was this morning, and it's supposed to be 20-mile-an-hour winds and go down to 18. So we may not make it out to the HD 10 today.
With the other guy yesterday, that's when you go out.
Yeah, I know. Well, that's because it always happens that way. Okay. All right. In the black cabinet, we're going to call it a cabinet. Thank you. There should be 2 motors, 2 electric motors. Grab the 2 electric motors for us, and then someone else who's never measured voltage or amperage. We're going to get you guys. We're going to get you to come up here, Mr. Peel.
Quick question.
Yes, sir.
Is an Ultimate 8S unit
Yes.
steel bay bottom of the ramp?
Yes.
We're going to throw it away.
Yes.
You're free to pick over.
Yes.
For sure, we probably want to take the shipping bracket
Yeah.
off.
Oh, absolutely. Because that's one that they don't have to make. Although they've already made 6 of them, I think.
Jim Ryan has been instructed to throw it away.
Okay.
But I will tell him to not throw it away until you tell him it's ready.
Okay.
How's that?
That'd be great.
All right.
And then there's the other one in Steel Bay that goes to Toyota. I don't know. Where'd you guys put the one in Steel Bay yesterday?
and then it should be marked Toyota.
Well, if you open the door, it'll be
Yeah,
marked.
and it's still on the valve too.
Yes,
So we're good.
because you tell me to do that, and I listen.
That worked out very well.
Oh, it worked out really well. And then the wheels didn't bend.
All right. Thank you, gentlemen.
All right. Thank you, sir. Yeah.
Have the gimbal.
No.
$17,000. You're just gonna throw it away.
Yeah.
Is there any particular reason?
I'll give you my address. Go ahead.
So that one there. So if it was built, if that ADAS was built pre-production before February of 2023, one of the small things is the cabinet doors, the doors on the tower open to the front, so the rail can come down and hit the doors because the doors open the wrong way. They open the doors this way so that when you were working on it, you had lots of room. Because now if you notice when the doors open this way, you're sort of stuck between the door and the rail. But at least when they open this way, the rail can come up and down and not have to worry about ejecting something out of very violently. The other thing that we do, if you return a gimbal that was made before a certain time in 2024, we call it a recipe. There are various different recipes as how we put, it's like how you make the sausage, right? There's different ingredients. So we use different recipes in our gimbal. Anything between a certain time in 2024, we have changed the recipe so much that gimbal to us, we can't even use it as like a core, right? We need those gimbals back because we're trying to keep them out of the hands of China so that they don't duplicate our technology, because we didn't even patent the gimbal. The gimbal is what we call a trade secret, because when you patent something, you have to tell the world how you did it so they can reverse engineer it. So we purposely haven't even patented the gimbals. We keep it an industry secret, which is why, never mind. So that's why we put a $4,000 price tag on it, because you're probably not going to spend $4,000 to give it to whoever was married to Eric Swalwell so she can take it back to China, right? Yeah, that one, right? What was her name? I forget her name. So we put a silly amount of money on it because you guys, it's under warranty. The customer is not going to pay the $4,000. We figure most of you guys aren't going to pay $4,000 to keep a gimbal around as a paperweight. So we get it back, and then we can do whatever we need to do with it before we recycle it. Because it's just, again, the recipe has changed, or there's enough different parts inside of it that we so.
So what becomes savable on that?
The PC, I will keep the gimbals just in case we have problems like we did in the hallway. I'll keep the gimbals. I'll keep the cameras, right? You never know when they have a camera issue. No wires. Probably not even the green board. I'll probably keep the USB box that puts the keys in it, because you can use that. Like if I need to make another standalone aligner for the hotel. The one piece that's super hard to get or super expensive is the USB box. So if I can take that USB box and I can make another piecemeal aligner for the hotel. It's weird when you're at this level, you're still trying to save the company money, right? You get a little higher up and you're just throwing away $70,000 worth of stuff, and it's like, it's Wednesday. So we're just throwing it away, right? So. They're there. I guess I'll have to send you the picture of it, because I guarantee you there's 2 of them there.
Super nice, but
Yes.
they're pretty worthless.
So you'll probably have to add, what's the newer lady's name? I'll have to get David to tell me the newer lady's name again that's in charge of the hotel. I guarantee you they're there.
The owner or the manager, I'm not there on that because I asked her about waffle maker.
Yeah.
She said no, they just got rid of them because no one was using them.
Oh, in the kitchen. Are you allowed to have one in your room?
No, I wanted it for the breakfast.
Yeah.
You can put a piece of burger, bacon, your vegetables.
Oh, grilled cheese sandwich? Yeah.
Waffle.
You would put a
I would, yeah. I have a reason.
disgusting human being. All right.
Every Saturday morning I make waffles in my room. They're $5 a piece.
Yeah.
They're on
So,
serve.
I'll go to
Right. I got a lot of $5.
anyway.
Shut up.
Yes, so just pieces parts. The PC's a PC, right? There's nothing different than that PC than a newer PC. That one is so early that one may only have 4 gigs of RAM in it instead of 8. But if I need to make something, it's still a PC, right? So, but none of those parts leave the building, right? Well, unless it's for the hotel, but none of the parts leave the ownership of Hunter. You guys would be mortified to see the 30-yard container outside of the engineering department that's full of 2-week-old stuff.
What do you guys call those things? Like they're like basically the antennas that talk from the tower.
Oh, the I/O gears?
The IO
So that I/O gear, I guarantee you that I/O gear is on 71 firmware. It's like 3 years old.
Office space that.
Right. Yeah. So, yeah, there's very little. Now, I do have a crash cart. One of the ones we were throwing away, I stole a lot of other parts to make a crash cart. I saved the counterweight. I saved the motor. I saved a lot of the green boards. I saved a gimbal. We took the gimbal apart so you could see how the sausage is made on a gimbal. So the crash cart is across the hallway, because most people, service people, like to see pieces parts. You need to see what it's at. We'll see pieces. I'll probably wait and do that until the dad comes on the 5th week from the Dominican Republic, so he can see pieces parts. Otherwise, I just got to show it twice. I'm already doing it once. All right. So so I need somebody over here who isn't proficient with a multimeter. There is no shame in this. Honestly, because you either used one or you hadn't. What we're going to do is we're just going to go to Omega Signs. okay? Because I'm not measuring amperage and I'm not measuring voltage. I want to measure resistance. And somehow resistance is the Greek letter omega. My Greek mythology is a little rusty. I'm not sure who the god of ohms is, but something. So we have three. So this is, you have to be careful because one of these wires is green. That's not a ground. That's a leg of power because it's not yellow with a green stripe. So well, welcome to Europe, right? Hey, in Europe you can get a bidet. Okay, so there you go.
Bidets make sense. This don't make no fucking
I've
sense.
never found a bidet when I was there.
Really?
Yeah, I don't know.
I don't know. I've never been.
Hotels?
I've never been. Right? I've never been. The Motel 8 in France probably doesn't have a bidet, right? So
Hey, you can buy one now that attaches to your water line on your own toilet.
I bought one of those officials.
Yeah.
so Matt Wise went all in, and rather than just buying the seat, he bought an actual toilet bidet at Home Depot. It's like $1,000.
Does he like it?
He loves it. He loves it. So anyway, so what you're gonna do is you're gonna measure from red to blue, and then you're gonna measure from red to green, and then you're gonna measure from blue to green, because that's the only way to get all three legs. Okay, and then we're gonna watch the resistance. Okay. So we have 5 ohms, and we keep it on the red and go to red to green, and we have 6 ohms, and now we're gonna go blue to green. And we also have 5 ohms. So we have 2 legs of 5 and 1 leg of 6. All right, now we're going to measure this motor, and you're going to do the exact same thing, but I'm not going to say anything. So the first leg we have 5.9. The second leg we have 5.9. And blue to green we have 5.9. All right, so I'll tell you what, since he's videoing, do it again. So again, I have a 5.0. All right, I have a 6.0, and then the other two, I have a 6.0. I have a 5.0. Okay, so I'm gonna wait for him to come back because he saw my ohms and he smiled and he walked out. So I'm gonna ask him a question when he gets back. That's all the measuring we're gonna do for a little bit. Okay. All right. Thank you so much. But that is. So again, if I wanted to measure resistance on this, I'd have to unplug it from the wall, and you're just measuring from, ground to ground, hot to hot, and hot to hot at that point. Just the other day, rather than having Jess do that, I'm just like, every time I dropped it, so I figured something was wrong there, so I just told him to take it apart, and sure enough, 2 of the screws were loose. I don't know how they get loose, but 2 of the screws are loose, so. Yeah, it's totally. Well, it's inside of plastic. What are they going to do? Touch each other? Fine, we'll blow the breaker. We'll find out which breaker it goes to. Right? What's the worst could happen?
That one.
Yeah.
Okay.
Yeah, resistance.
Yes.
If you notice, it has a picture of like a resistor. That's the electrical symbol for resistance. For whatever reason, that's the Greek symbol for resistance. I don't know why we're still doing Greek symbols, but we're still doing Greek symbols. You're good. We're in the middle of a bathroom cycle, so I'm gonna wait till people cycle in and out. You're good.
I was gonna do that.
Well, fine, do it. No one's here. Stand up and do it.
Waiting.
All right, we ain't got nothing but time.
Does it matter whether
Resistance is multi-directional. Resistance is resistance. Amperage and voltage matters. You can get positive or negative amps or volts, but resistance is purely resistance. So the one thing I did, and the one thing I didn't have the other gentleman do, and I should have. Hey, Steve, you bring your meter back up here. The other thing that I didn't have the other gentleman do, and it's very important, is we checked we checked the field windings to the field windings, but we didn't check the field windings to ground. So you want to check all 3 of these field windings and just hold either the red or the black to the case. So do case to case, because you want to make sure that you're actually be able to measure, right? That you're not on a painted spot or whatever. Okay. So now do it from here to here, here, and here, and you should get something Okay, that's good. You get OL. OL stands for out of limits, which means the field windings are not in. So keep the red on here and go from here to so check it, and check it. And you should get OL, OL, OL all 3 times because your field windings are encased in some wrapping and the field windings can't be touching ground. Otherwise, that's why they call him Mr. Sparky. And he gets an award and you get an award and the circuit breaker gets an award and everyone gets an award because, okay, thank you so much, Mr. Steve. So you always want to check field windings to each other. You always want to also check field windings to ground. Again, if you are grounded, you're usually, the other 2 legs may not be, and every time it gets to that 3rd leg, you will see sparks shoot out the back of the motor. That's actually kind of cool, especially at a couple hundred RPM. Stuff's flying out the back. Looks like a crash in Fast and the Furious at that point, right? Pieces and parts are just sort of, yeah, stuff.
Then rivets come out of the floor.
Yeah, that happens too. So,
The snap on impact,
Oh,
had the first one.
did it? Yeah.
Yeah, it would throw sparks.
That's
That's kinda
hilarious.
cool. I never fixed it.
Yeah. So, but you always want to check it to ground also. Okay, it's just it's a quick, simple test, but it's important. Okay. All right. So again, I have a question, but I'm waiting for everyone to get back in here. 1, 2, 3, 4, 5, 6, 7, 8. All right, 2. Okay, that's fine. I said on day 1, I'm like a mama duck. I always have to count my ducklings because at some point I'm missing somebody, and then I have to figure out how many I'm missing. So.
We do a pretty good upstage together.
Mhm.
Where's that coupling where it connects to the reservoir on the back of the Revolution? Or is that a different motor? Didn't you say yes?
Oh yeah, so that's just only on the Revolution. Well, we have couplings. We have 2 different types of couplings. So the coupling on a Revolution is a double coupling. So it has like it almost makes like a slotted screwdriver. So I have a vein coming down and a vein coming up on this end, and then the coupling itself is like almost like a gender changer, where it's the same on both ends. So then I have a vein and a vein, and that's why it's a little hard to set the depth because if I pull the coupling up too high, then I miss here. If the coupling is down too far, then I miss the top. No, it's metal. It's metal and it shears wonderfully and it sounds fantastically bad. And how do I pause this for a second? Yes, sir. Hey. I bet it wasn't. What happened? What happened? Okay. Oh, okay. 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 There's no bushes. Okay.
Just move over to into.
The bushings. Yeah. So, well, did they charge you money or they do it for free? I'm sure they charge you. Did they really? Wow. Okay. Okay. So yeah, sell it for the 1,500, and just tell them it needs some more.
It's usually for like your fighting, even out at the big colors.
Right. I understand. Theoretically, they were highballing you. You don't have to take the motor out to put cradle bushings in, but they're going to tell you that just so they can charge you a lot more money. Because what they would do is they would suspend the motor with like a cherry picker or a special thing. You can drop the cradle down one corner at a time and put bushings in, but you got to know what you're doing. It's just, and they're just trying to make money, and I get it, so I can't hold them against it. But they were nice enough to check the car out for you. And at least now you know what the clanking is. And again, Barbara, she made it all the way from Atlanta to Utah with all that wrong, right? So, Absolutely, I totally agree with you. He sounds like a nice guy. I'm sure he is. So, all right, well, very cool. Well, at least you know. All right, thank you, sir. All right. Okay, let me see if the customer will accept the training center. All right, so that's Dave. Got Dave. Fine. Don't have to worry about that. That's answered. Don't have to worry about any of this because. Okay. Do I have 10?
Mm-hmm.
All right, I'm gonna put the lav mic back on. So, one of these motors, all three legs or all three field windings measured out 5.9. The other motor, I had two field windings that measured out at 5 ohms, and I had a third leg field windings that measured out at 6 ohms. So I'm going to ask you, are both these motors the same? Well, could you are they in the same condition? Would you continue to use both of these motors in a tire changer? Okay. So when I came to training, because I was out in the field for 15 years and I didn't know this either till I came and sat in with the venerable Clay Johansson. The one that's in 5.9. Okay, because we are inverting and we are making a third leg of power because it's hooked up to an inverter. The inverter has to work evenly. The inverter that has to change from 5.0 to 6.0 to 5.0 to 5.0 to 6.0 to 5.0 is working 90% harder. And you are going to burn out the inverter because of 1 ohm of resistance in your motor. Like the first inverter you put on will probably last 3.5, 4 years. The second inverter you put on is probably going to last 6 to 8 months. And then you're going to put on a second inverter in 6 to 8 months, and that'll be the third inverter on that thing. Okay, I had no idea that 1 ohm of resistance is going to cause that inverter to work that much harder. That's my wonderful Canadian friend Monique. So she's got 2 Canadians next door, and they both speak French. So she's like over the moon. She can talk to somebody. She translates French and Spanish. If you see on the product support, if you see a French or a Spanish, yeah, that's her. So anyway, 1 ohm resistance, right? I can't tell you how many of these motors that I didn't know because I wasn't trained, that I didn't know that by leaving that motor in with 1 ohm difference, that it was causing my inverters to work 90% harder. Okay, so anytime you're doing an inverter, it kind of stinks because normally you can't get to the legs of power until you take the inverter off, right? We're getting better at putting inverters in accessible locations, but most people are going to come in and you're going to be like, hey, my tire changer doesn't spin, and you're going to step on the gas and nothing's going to happen, and you go, yep, you're going to need an inverter. And then you're going to give them an estimate for an inverter. Our universal inverters, which fit 11 different tire changers, are at the low price of like $1,850 because it's a universal inverter. Imagine if it wasn't a universal inverter. It'd be crazy. So you're going to give them an estimate for like, I don't know, $2,600, 25. Let's see what $2,500 by the time you throw in a trip charge and some labor and some shipping. Then you're going to get out there and you're going to start to replace the inverter, and then you're going to be like, oh yeah, Jim told me to check the motor. And then you check the motor. Now you need an $800 motor. Oh, because the guy's already in for two. Now the guy's going to be in for like $3,300 or so, right? And maybe you'll be like, dude, I messed this up. Just pay for the motor and I'll give you the labor, right? Because you're at that point you're already in a compromised position, right? You do what you need to do. You're on your own business, but at some point you're going to be like, oh. So try to own your, at least let the guy know, right? Like, look, if it just needs an inverter, it's going to be this much money. If it needs an inverter and a motor, it's going to be this much money. I can't really get to the motor wiring till I take the inverter off the truck. I don't have, I have the inverter on the truck today. I can try to see I can try to replace the motor today, check out the motor wiring. If you need a motor and I don't have it though, you're still going to be down for a few days because I don't want to put my new inverter on a motor that's causing it to work 90% harder. So you're going to be the bearer of bad news, right? Because he's already down a day or two. You get out there, you're like, hey, good news is I can fix it. If it's only this, if it's this, then we're going to talk. And at $3,300, which is way different than $2,500, that's the point where you turn into a salesperson almost at that point, right? You're like, this fine piece of equipment here, it's 12 years old. It just came off the brand new refurbished Hunter assembly line, right? So even if you spend $3,300 in it, the whole rest of the tire change is 12 years old, right? You get some slop, some play, some movement, things aren't right, the dentures don't quite fit anymore, stuff like that, right? So you guys will have Dave Henry for strategic selling, just like the sales guys did yesterday. Dave Henry does a phenomenal job, so I just let David Henry do that. He's in his domain. All right, he's gonna have a good time because he's got 10 of you guys, so we'll probably get the media room again for you guys. That'll be week 7, week 8. So anyway, that's why at that point you become a salesperson. That's why you sell the next piece, right? Hopefully you don't have to do that the first 6 months you're out there, right? Because they're gonna be like, dude, you're new, you just don't know how to fix nothing. You're like, but it's 12 years old, right? It's like, come on, right? It's like in dog years at that point, right? It's got bad kidneys, it's got bad knees, it's got some type of arthritis, poor things, got diapers on it. Come on. So you have to be careful with that, okay? All right, so if you'd be so kind as to take that back, unless someone else wants to do ohms or anything, we're all good. Okay, if you want to put that back in the case where we got it from, we're gonna step up to the pump. Yeah.
Is that true for all? I don't do the AC stuff from cars. Is that true for all inverters?
I can't answer that question. I would love to be able to answer that question. I just know it's for us. Clay probably had a YouTube video that explained it that 6 years ago I might have been able to find. Clay was really good at documentation and backing up his claims. I knew when Clay said it, I wasn't going to argue it because I was going to lose. But I can't tell you if it's outside of a Hunter or not. Okay. I wish I could. I'd love to, but all right. This motor here, the little sticker over here says this fits either an Auto 34 or an Auto 28. If you gentlemen see an Auto 28 in the wild, do not make eye contact. Back away slowly. Call somebody. Okay. You do not want to work on an Auto 28. All right. Auto 34s, however, you're going to see these all over the place. So again, that's why you have to look for the little hickey-do so that you take your ground here. All right, because I got a ground in 2 hots. You're going to plug in the little hickey-do. Everyone see that little cool flash of plasma right there? Okay. That scares most people that aren't used to doing anything with AC electric, okay? It scares the end user because he's standing there. Usually it has a metal, for whatever reason, commercial buildings have metal wall plates.
It makes no sense.
They go to the trouble of putting in all the 110 outlets upside down so that if something falls on it, it hits the ground tab rather than the hot tab. But they're going to put a metal wall plate around 220. I don't get it. So the last thing you want is you want that little pop of plasma and that little smell of ozone, like Christmas Story, right? Right? You don't really want that. So we actually, in later years, we came out with a different inverter that minimizes that. It's called an inrush inverter, so that we're not, because basically what that pop of electricity is we are instantaneously filling up our capacitors. Cool. We are instantaneously filling up our capacitors, okay? So on the inrush inverter, there is an open in the wiring right here, right? right? I can, yeah. So if I move this just in the right, I can make this thing do cool things. Okay. All right. That's the cool part. All right. Stop it. Stop it. Stop it. Stop. 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 It's in one of the. A pin is loose inside the pin. It'll be fine. So we're instantaneous. The only thing was is it put it on when I was touching the caps. I was like, I don't want that. It's gonna hurt. So, okay. Inverters. Again, I only have single phase coming in. I have 3 phases coming out. So gather around, children. Okay. Someone grab a. I need a pocket screwdriver. Thank you very much. Since it's your pocket screwdriver. The reason this is on here is because this is like a breakout box. So if you could put these in there and screw down the little screwy screws. We're going to go to railroad tracks on voltage. Or is it AC? No, it's DC. One of these wires is just, it's just enough to just annoy me. Tap, tap, tap. It's like talking to your cat. It's not going to listen. It's going to do what it wants to do anyway. Okay. With this breakout harness, that way you don't have to back pin or back probe the connector. If you're lazy, you're just going to stab through the wiring harness and then make a hole in the wiring harness, and then you're going to invite in corrosion and stuff like that. And then that was Mateus, right? Okay, fine. As long as it was Mateus. So what we're doing here is we're pulling out the 2 wires on our potentiometer, because I have to measure my potentiometer. So my potentiometer is right now measuring 6.5. Okay. My potentiometer right now is actually supposed to be reading 0.510. Every class adjusts it, and then every new class that comes in, it's never on 0.510. It just doesn't, okay? It's just a thing. So what I'm going to show you is, where's it at? Somewhere, I think it's down here, there's a set screw. So on the back side here, you have to unloosen. You have to loosen the set screw. Then you have to take your pocket screwdriver, because the potentiometer has a slotted screw. You have to turn the potentiometer while you're trying to get, see now it reads 0.51, right? Because all I did was move it up and down. So it returned it, okay. You have to remove the potentiometer to 0.51. As you tighten the set screw, what do you think happens to the potentiometer? It turns, right? So the person who's going to try this is going to hate that they volunteered to try this, because they're going to be doing this for about 10 minutes, and I'm just going to go sit down over there and smoke for a second. So, because it's every time you do, it moves. Okay, so this is one of the wiring harnesses that either I told you to order or comes in your initial stock order, okay? If you notice, the voltage as I push down, we call this a ladder. The ladder is going to twist the potentiometer. It starts out nice and slow, and then it goes faster. Okay, it gets all the way up to about 8.5 volts. If you notice, when I let off, there's an electronic brake. It doesn't keep spinning because it's 3-phase, and I can do that. Okay. If I pick up backwards, I don't move. This is a kind of an interesting pedal. I don't move the ladder, and I don't move the potentiometer. I'm just closing this normally open switch. Okay, it's just single speed. Okay, and then that just gives me 1 speed in reverse, because most people don't want multiple speeds when they're turning the tire backwards. They just want slower or faster, because most people break the beads this way. They put the tire on this way. Every once in a while, you have to back the tire up for TPMS position. So I don't need multiple speeds to go backwards. So single, and then again, if you notice when I do this, as soon as I let off, it stops, which gives you really nice control on the tabletop. That machine over there, the TCX51, that doesn't have an electric brake. So when you let off the pedal, it sort of coasts to a stop. So it might move a little bit more than you want it to. Okay, and I'll explain that one in a second. So again, the reason you want it at 0.51 volts is if this thing is sitting at, like, I can get this thing all the way up to about almost 1.5 volts. Okay. What's happening is I am putting voltage to this motor, but I'm not giving it enough voltage to turn. It is putting voltage in here, which means it's getting hot. If the fan isn't running, the fan isn't pulling air in to cool it down. If you don't have this right when you come in the morning, this is going to be a puddle because the motor is just getting hotter and hotter and hotter and hotter and hotter, but it's not spinning to cool itself off. And because we have a plastic fan and a plastic fan case, because we're saving money, it's going to be all melted together in a nice congealed ick. And then you'll have to replace the motor and you're still going to have to set your 0.5 volts. Okay, so we just need a neutral. Also, for that sake, anytime you plug in a tire changer with an inverter, they tell you to wait 15 to 30 seconds because the inverter has to relearn what neutral is. So if you plug the thing in and you hit the gas, it's going to think that that's neutral. And then when you let it up into neutral, it doesn't know what to do with it. So you always give it 15 to 30 seconds. And most people are not going to be like jumping right in.
So does that mean that we're setting the pedal for neutral to 0.510, or this one has just learned that neutral is 0.510?
No. You are actually, it's supposed to be set to 0.510. When we first plugged it in, it was a little high. And if you notice, every time I move it back and forth, the potentiometer and the voltage is all Nikola Tesla, and it moved from 0.6 to 0.5.
That's
Right.
typically for all the potentiometers on these.
Well, the Auto 28 was 2.7. So if I had an Auto 28, it was 2.7. If I had an Auto 30, all of our Auto 34s are 0.5.
And that's why I asked, so like some throttle position sensors, early ones were self-zeroing
Right.
somewhere.
Yeah.
Yeah,
No,
base.
you need to set it up. It will not learn. It's just gonna take whatever it is, and that's what it is. We're not that smart. Well, the Italians aren't that smart. Someone's not that smart. Okay. All right. No, you have to manually set it. That is a manual adjustment. Where is my?
It's right there.
Oh, it is right down there. Yeah, it's like I don't know. It's like a 3/64 set screw on a
I'm assuming this
perfect
right
upside down angle. Yeah, that one. Whatever that is, which is why we keep it right here, because I got so tired of finding the right one. So now it stays here all the time. Okay. The next thing we're going to talk about, I'm going to break out some, I'm going to break some other stuff out. So I'm going to walk this way for a second. One of those you had to order, the other one comes in your initial stock order. There are two different versions of this harness. This is the 5 conduit harness. The other one is only a 3 conduit harness, and it depends on which tire changer you have. Obviously, when you pull the thing apart, you're just going to go, oh, I need the 3 or I need the 5. It's fairly self-evident. Okay, so we're going to talk about dip switches. And we're going to talk, no, actually, those are not dip switches. These are dip switches. We're going to talk about dip switches. That's a 640. That's a 640. Dip switches, okay. Because this is a universal inverter, this is in the instructions when you order in a replacement inverter. I don't know if we give out the instructions anymore with the replacement inverter, but you can find it online on the sales and service website. We have to plug in the motor leads in certain places, and we have to set the dip switches on the inverter to certain places to make certain things work. Now, the good part is if you mess this up or you mess this up, you don't blow anything up and you don't melt anything down. It just doesn't work right. So it is recoverable. It is a recoverable problem. Okay. So if you notice this one here, I have 5 different wires going to it because I have a 5-wire harness, not a 3-wire harness. If you notice, number 6 is actually in number 8, right? Number 5 is in number 5. All right. Actually, no, those are dip switches. Sorry. So wait, 8 is all the way against here, so it goes this way, right? So 8 is there, 8765543. So I am looking for 6. Auto 34, Auto 34S. That's interesting. I got 5. Oh yeah, 6 is actually number 2 and 5 is here. So it is wired right. So 5 actually goes into 8, 6 goes into 7, 3 goes into 6, 4. None of them, although 2 goes into 2. All right, so we got 2 right, okay? All right, so again, you have to put the leads from the from your potentiometer and your reverse switch into the right spots. But then you also have to, and here's your dip switches right here. If you notice, those dip switches look really big, but they're really, really small on the board. So you're going to have a really nice pick. Normally, all I care about is I care about the word on, because I don't even think this thing says off. I think that only says on. So I have to do everything towards, is it towards on or is it away from on? Because it doesn't actually say off anymore. Like here, it only says on, right? There's actually no off on the actual dip switches, okay? These dip switches are the same dip switches that are found in the K-Key remote that you saw. There's only 4 instead of 6. There's also on racks in the rack console, we have to set the cordless channel in the rack console. So the rack console will have 4 dip switches, just like the K-Key. So you're going to constantly be seeing dip switches over the course of your career. Again, it's always in relationship to on, right? Are all 4 of them on, or all 4 of them not on or away from on? You get one up, one down. That gets a little tricky, right? You have to, am I looking at it this way or am I looking at it this way? Again, this isn't anything crazy. This is just out of the manual or the installation instructions. We just took that page, and we just laminated it so that we keep showing you guys what's going on. If you flip it over, one of them is going to show you the wiring. Again, thanks to Josh, we use UV and W because that's the industry standard for 3-phase power. If you notice, UV and W, depending on your vintage of tire changer, one of these colors is different. Right? I have green, red, black. I have green, red, black, and green, red, blue. Depending on if you're using one that my grandfather used, you probably have the first version of it. If you got one that just came out today, you're gonna have the second version of it. But again, that's probably just because whoever we bought the motors from wired them with different wiring colors. Okay. Again, you just get 2 hots and a ground. So if you notice, I just have 2 blacks right here, 2 black wires right here, and then I have my yellow with my green stripe, because I'm trying to. If I did this accurately, this one would be blue, this one would be tan. And 110, it gets a little, I never figured out if it was, I think we should have looked at the on-car brake lathe. I think blue is neutral and tan is hot in 110. I'd have to take the on-car brake lathe apart, because you'll notice one of them goes to the variable frequency drive and one of them doesn't. It's fine. Okay. So we get our inputs, right? So all of our inputs are in this corner, and then we have UV, and for some reason W is around the corner. I guess it's just because we didn't have enough room to fit it up in here. Okay. Josh knows there's another funny thing that Nikola Tesla will have to explain to me. If you take 3-phase power and you get 2 of the legs wrong, the motor's going to spin backwards. At that point, you don't have to take these 2 legs and you can take these 2 legs and do this. On a 3-phase power, all you have to do is take any 2 legs and swap them. And somehow that causes the motor to spin in the other direction. Do you care to pontificate him on that? Because it's magic, and you just move it. Yeah.
So yeah, you're moving one of the phases.
Yeah, and I guess it depends on if it's going up in power or down in power. It causes the motor either to spin this way or to spin this way. Every time we replaced the 645 in HD Bay, you just wire it up and you plug it in, and then you watch the fan, and the fan either spins the right way or it spins the wrong way. And every time we wire it up 6.5 years, we always have to take the plug out of the wall and take 2 of the wires and just flip any 2 of the wires, as long as it's not the ground. Never flip the ground. Any of the 2 power wires, you just flip them around, and then all of a sudden the motor spins in the right way, because rather than making pressure, it's making suction. All right, so it's super easy. Does the hydraulic ram move or does it not move? And if it doesn't move, well, congratulations. Spin it, plug it back in, and then all of a sudden the hydraulic ram goes up and down. And then you're like spiking the football and, you know, taking the trophy home because you managed to get three-phase power. Right? It's just weird that way. It's just a weird anomaly that you just, okay. So so this is the small original inverter. Okay. The little blue box right here is where all the magic happens. That's how we somehow come up with 3 phases instead of 1, technically 2, but I'm not going to argue it because it annoys me. It just, yes. Anyway, so this is where we're somehow making a 3rd phase, 3rd leg of power. I don't know how it works. I don't know how that little box does it because you'd think you'd need something as big as this room to make 3 phases of power, but we shrunk it down. Evidently, honey, we shrunk the transformer at that point, right? Okay. The little red heartbeat light. The one good thing about Hunter Engineering is we usually have a heartbeat light on our circuit boards just to let you know that the circuit board is on and running. Okay. That heartbeat light right there is a once per second. When you're booting up a balancer, it starts at once per second, and once it boots all the way up, it flashes twice per second to let you know that the balancer's finished booting up and now this thing's just ready to go to town. But we always have a heartbeat light. So if you'd be so kind as to unplug me. And then you can undo my, thank you. All right. Obviously, as long as the red heartbeat light is going on, it is waiting to reach out and touch you. So you usually just wait until the heartbeat light. Since there's no capacitors, you can't drain. Well, it has capacitors, but because it's not a rotary switch, it's a potentiometer. You can't drain the capacitors. You just have to sit there and wait until the heartbeat light stops. When the heartbeat light stops, it is flatline, just like in the Pit or Grey's Anatomy or whatever, right? Flatline is flatline. So at this point, it's safe to touch something, and you don't have to worry about becoming Steve and his panel experience, which is interesting. Okay. Pretty straightforward, pretty simple. Again, this is the original size of the original inverter. The original inverter got bolted directly to the motor. There was a bottom piece that had to cut out with a gasket, so we were trying to keep water out of it. And then it fit between this and the floor. Okay, you're going to grab that piece of wood right there. You're going to take that motor out your way there, Michael. All right, there you go. I'm going to put this one in this way. No, I was going to try to put that one in this way. All right. This one is the newer inverter, which we call our inrush inverter. For those of you versed in 1980s fuse panels, that's a 25 amp fuse because it's an off-white. It's not quite yellow because yellow is a 20 and green is a 30, and that off-white color is a 25. Got to go all the way back to like ALDL connectors where you put the thing in and measured the, watch the blinks. But yeah. So there's your 25 amp fuse. Yeah, put the paper clip in it. Yeah, that was fun. All right, so we're going to watch as Jared here risks his life to plug that in, and you're going to notice that the plasma rush there is, right? If you notice, you didn't see one, right? Right. Oh, did you actually twist it? Mm-hmm. All right. You gotta. That ain't going nowhere. Okay. I have a heartbeat light again. So my heartbeat light's letting me know I have voltage on the board and everything's booted up and everything's running fine. These wiring diagrams still work. So my UVW, this and my dip switches, still the inverters use the same. Yeah, I know, wasn't it? I didn't do it, so I can't take credit for it, but I'm actually happy they did it. So you can wire it up the same. Okay, so as you notice, this is a 3 conduit because I only have one potentiometer. I don't have a reversing switch. So it's a different pedal design. We decided that by not having a switch, we could We could save money. So we're going to save money. A much bigger heat sink. The other heats, this heat sink is probably as big as that whole entire inverter. Now my inverter is about, 35% bigger. I have a much bigger heat sink. Again, hey, this one actually has the coloring. Okay, so I have blue and tan, and my yellow with the green stripes. My yellow with the green stripe is ground. I have blue and tan. Since this is 220, they're both hot. However, if you notice, we've added 2 new black wires, and the 2 new black wires say T1 and T2. The other thing we did in later years, what that motor doesn't have, this motor here has a thermal switch. The thermal switch is non-resettable. So if you pop your thermal switch, you are replacing the motor. I don't know where the thermal switch is in the motor. I haven't really cared to take one apart to find one. However, you obviously are going to get caught with your pants down because you're going to check the ohms on the motor, right? You're going to check your 3 phases of ohms, and your 3 phases of ohms are going to check out, and you're going to check them to ground, and it's going to be OL, but you're going to forget to check your thermal switch. So your wiring checks out good, but the motor's still no worky. And then you've got it all the way back together at that point, and then you step on the pedal, and you get that really deflated feeling in your stomach, which usually comes out the other end, because you probably know at that point you're taking this thing all the way back apart just to ohm out the thermal switch that you forgot to ohm out. And at that point, instead of your thermal switch being 0 because it's closed, it's going to be OL because it's going to be open. And
What's
then
the purpose of using non-resettable?
Just like the people you work with, you still work with people who are the lowest common denominator, and we don't like some of our lowest common denominator people messing with 3-phase motors. You can probably do it. You can probably do it. Y'all can probably do it. But there are some people in South Florida we would rather. No, I'm just kidding. I love the state of Florida. I'm going to retire there one day.
I agree with that.
That's why if you want to, any day of the week, just go out to Google and type in the words Florida man, and it will auto-fill in what happened, and the stories will never disappoint.
Or you put your birthday in and see what.
Yeah, Florida man, birth date Florida man, and did he wrestle an alligator? Did he catch a shark in a parking lot? It's Florida. Florida man will never disappoint.
You're saying they filmed Walking Dead in Griffin?
They did.
Yeah, they apparently designed it and created the characters around me about 20 years prior.
Okay.
I've been growing with it.
But yeah, no, that's Griffin's claim to fame. The Goodyear store that I was at was actually one of the stores. They had an automotive shop in The Walking Dead, and the Goodyear store was the Goodyear store until 4:30, and at 4:30 they had to be done with all the work. All the cars in there had to be taken out so they could pull in new cars. They literally filmed from like 4:30 at night to like 4:30 in the morning. They had enough lights outside of the Goodyear store that it looked, if they needed it to look like daylight, they were filming in the day at like 2:30 in the morning, because they brought in, just insane amount of lights, right? And then at early 7 o'clock the next morning, the Goodyear dealership, the filming crew had to be done. They had to take all their stuff out. They didn't move any of the equipment. They just moved the cars in and out. So it was quite the. I'm sure the Goodyear place made more money on The Walking Dead than they ever did fixing cars. Good for them, right? Capitalism at their finest. So again, this is just a 3-wire one, so I only have the 3 wires right here. I have my tan again. So what I'm doing, just like on the Revolution tire changer, I only have 1 fuse, right? So if you notice, the blue goes right into my inverter, and the tan wire is interrupted by the non-resettable thermal switch, right? Because on 220, if I open up one side, I can't do the whole AC thing where I go back and forth, right? So, and then I save by only having 1 thermal switch, right? So there you go. There's a theme here. I get my blinky light. Again, you can see the dip switches. You can see, these guys here. These guys here are really cool. if I push in with my fingernail, I can pull this guy out, and then all I have to do to put this guy back in is all I have to do is push that guy in, and it's like backstabbing on a residential thing where it's just catching it and holding it with like spring steel or something. But taking because it was losing an input, so the motor started to turn, and when the motor starts to turn, it gets that electrical whine. So when I was unplugging and plugging it, it was letting me know that it was unhappy.
I was like, they put a little speaker in there?
No. So if I go forward again, low speed, all the way up to high speed, let off, it stops, and then backwards, we figured out how to take the same voltage off the potentiometer, but we're dropping below a half a volt, and then it knows to go single speed in reverse. Okay. All right. So the other thing, if you noticed, this motor is not open right here. There is a cap on it. When you order a new inverter, the new inverter comes with, you can either call it an umbilical cord or you can call it a remote. It's like a remote placement or a remote, it's called a remote something, because you don't mount this inverter anymore on top of the motor. This inverter is way too big to fit up here. So they give you this remote inverter. It's a remote tether. Fine. So basically, all of the wires that are coming out of here are all the wires that are coming out of here. These wires are just numbered T1 to 5, and then you just have to match up. It's all plug and play. All right, you have you have solderless connectors, right? You just plug them together. And then what happens is you're allowed to locate relocation kit. It is the universal inverter relocation kit. You get the wire here, and then you can put this in a much easier accessible place than where it is when you first took it out. Okay. Hey, we put the heat shield on here so you couldn't electrocute yourself, because all the 220s, all the fun 220s under there. All right, so we're being a little more safer over here. But this is what the relocation kit looks like. It's just a wire with a lot of connectors in it. They all look like this. So it's super easy. Just, pretend you're building a model car back when you're like 6 with the door closed, because you like the smell of the glue. Yeah, that one.
Now, if you have to order
And then
one of
people
these-
wonder why we're autistic. Yeah.
If you have to order one of these for an older unit, will the installation instructions online show you where to relocate the inverter box?
Yeah. There's a template, because you'll have to drill a couple of holes, so they give you a template. One of the pages of the installation instructions is 100%. So if you either print it out or you get the installation, you just put it up against the side of the machine. Take your clicky point, center punch, clicky point, center punch, and then you make it 2 holes. It's like a ballpoint pen.
They look really good on tile.
I'm sure they do. I'm sure I don't want to pay for the tile after I do it either.
No, you can get tile. Fine.
I'm afraid it'd be shattered. Okay. So basically the same. I have a potentiometer. It's either telling it to go high or low. Reverses 1 speed. Much bigger inrush inverter, so that when you plug this up, you don't feel like you're going to get electrocuted, because we don't fill the capacitors up nearly as much as we used to. Okay. When I unplugged it, you heard the inverter sort of click. It turned off. Now the red heartbeat light there is just going to... The good news with the red heartbeat light is it keeps blinking as long as there's power, so we do drain everything off the board by keeping the red heartbeat light going. Okay.
You weren't kidding about the hot glue.
No, we love hot glue. We will spooge out some hot glue in places that is, it's like Oprah. Everybody gets hot glue. Okay. So
You replaced the motor, does it come with connectors on it already? That's something you gotta...
no, it'll come with the connectors on it. Again, Florida man. So someone could take these and put these in the very top left of that open, just in that box right there, wherever. Next to it's fine. just somewhere up there, so then when Will does his next class, we'll be able to find it. If you could put that away, I don't think we're going to use that anymore. All right. The next style we're going to look at is so inverters are for the high end tire changers. If you get the 51 to 53 series, we don't use an inverter. We use something, I'm going to turn this around so that the camera can pick it up a little bit better. We use something called a rotary switch. Okay. A rotary switch sounds just like it sounds. Inside the rotary switch, there are two sets of wipers, and the pedal attaches to the guy here. And when you step down on the pedal, the rotary switches flip one way, and then when you pick up on the pedal, the rotary switches flip the other way. And by flipping, we're taking the AC waves and we're telling the motor to spin either forward or backward, because the wires that come off the rotary switch to the motor, loud and unexpected, the wires that come off the rotary switch to the motor, there's only one set of wires. So we're literally taking the AC sine wave and inverting it 180 degrees so that it spins. Yes. So if you could grab me a pair of vice grips, bottom left-hand drawer somewhere where it says pliers. Just a needle nose set is great. I don't need anything crazy. Okay, so for those, most of you, anyone besides Josh probably hadn't been inside of an electrical disconnect panel. Okay, normally inside of an electrical disconnect panel, there's springs so that you don't have to go. The reason there are springs is because as the wipers, as the wiper gets close to so there's like a male and a female wiper, and the thing swings in. Okay, as the thing gets close, you guys ever see that where there's servicing like 500,000 volt lines and they pull it away and the electricity's still arcing? So if someone's stepping down on the pedal and they sort of stop right here, there's going to be arcing and there's going to be pitting, and then the wipers are going to be so arced and so pitted they're going to be burned, and then the electricity won't flow through it. So in electrical disconnect boxes or in rotary switches, there's an internal spring so that once you get to a certain point, it just takes it and just goes wham. Okay, so this motor is not wired up correctly, and there's some broken wires like that one right there. So this motor is going to sound horrible, and it may not even actually start up in the beginning. I may actually have to take the shaft and twist the shaft a little bit because it doesn't know which way to spin. So I actually have to tell it which way to spin. Well, don't break, calm.
The ground was good. It looked good.
Yeah.
I just wanted to make sure.
So if you notice what happens when I push, at some point it's going to take it from me, right? And it closed because it wanted it to close as fast as possible. And then when I go the other way into reverse, it's going to take it from me, right? And then the faster it opens and closes, the less it arcs, the less it pits, and the less that switch there ends up burning. If you can say, it's fine, hold on, let me just do this. If you notice, you can see some brown here, that's actually burning, okay?
Nice.
Right, I got another one where you can see it a little bit better. So, again, this thing's going to make a horrible noise. Now the cool part is that's still spinning. If I go backwards, it's still spinning in the same, right? It's still spinning in the same direction. Because once the motor is spinning, it doesn't matter what the rotary switch does. The motor is already spinning, so it's already like, hey, let's keep going. We're going into town. Doesn't matter if I'm going the wrong way. So I have to, and if you notice, because it doesn't have an electric brake, this thing spins down like your old grandpa's bench grinder out in the shop, right? That thing will spin for about 10 minutes, right? That thing just keeps spinning. All right, so now if I do this and I pull it backwards, start. So that's still spun that way. And now if I go forward, let's go that way. Well, okay.
Doesn't like it.
That's Wednesday. So if I keep it going that way and I do that, it used to be a lot quieter, but
Sounds great.
Sounds like my garbage disposal when I first checked in.
it used to be a lot quieter, but
Is it one speed?
it is single speed. Again, because you're only paying $7 or $8 grand for a tire changer, we're not going to give you. It's a pain point, right? Yeah, when the salespeople sell it, do you need multiple speeds? Can you deal with one speed? Well, I don't know. The guy out back's doing it. I just want something cheap. So the old, you get what you pay for.
What are these on?
51, 53s, 50s, 51s, and 53s. No, this is a single. Everything about this is straight single phase. This here, lovely, ginormous capacitors are just waiting to meet you. Waiting to meet you. You have the pain behind these capacitors is wonderful. It'll have you seeing colors.
Have you done it?
Yes, unfortunately. So normally what you do is when you unplug the power cord, you take the pedal and you double tap it down, double tap it up. Because there's no electronics in here, there's no inverter. By twisting it in both directions, you normally drain the capacitors. However, if you get in a hurry and you forget to do that, and then you start replacing this and you forget to do that, it will drain through you, because at some point you're going to touch the wrong thing at the wrong time, and then things will hurt for about 3 days. Again, it's a rotary switch. Again, I have a wire here. I have no idea what that wire goes to. What I love about this is I have white going to pink. I have white going to white. I get the orange and the red sorta. I got white going to black with a teal. I got
Could be one spins the same direction.
could be. I used to pick on a guy from Georgia. He lasted about a year longer than I thought he was going to last. So I used to blame him for everything that was broken around here, but he's been out now for a while. So, I got a rotary switch somewhere over there. Again, this is just a pure single phase motor. Single phase forward and backward. They do give you a new one of these. You are supposed to take your hair dryer, because when you heat this up, this is heat shrink. Normally, if you're smart though, and you cut it on the bottom, and you put it back over on the top, the heat shrink, because what you guys don't know is the transmission for the turntable is sitting right on top of this. And the transmission loves to drip out some weird primordial ooze, and you don't want the primordial ooze going into the rotary switch, so we give you the diaper, and then it goes around, and then it just sort of finds itself in the bottom of the tire changer. Oh, I didn't talk about that. So, thank you. At some point, see these two little screws? They're like number 4x40 by like 1 inch long. These screws, because the thing gets shoved backwards and shoved forwards, one of these two screws is going to fall out into about 3/4 of an inch of primordial ooze. It's fun trying to fish that bad boy out, right? You're almost looking for the one-celled amoeba that's going to come out with you. When one of these bolts falls out, it'll work in one direction, but it won't work in the other, because when it tries to flip it, rather than this thing, the whole entire thing moves, and then you only have one direction. So if they ever call you up and go, hey, my tire changer only spins in one direction, congratulations, you're going swimming for that little screw there. The other cool thing about this is this motor right here, in that tire changer, this is what you get to see of the rotary switch. So now you're laying down in the rat pee with your hands extended all the way inside the tire changer, because only one side of the tire changer comes off, that side does not. So you're laying down in the rat pee in a prone position, feeling for the screw so that you can take the screw, spray it off with brake cleaner. Then you have to take this guy here and you have to try to rotate it back to where it's neutral. Then you have to put the screw in with your little stubby screwdriver to put that screw back in, because taking out this bracket is adjustable. You're going to spend the next half hour trying to get the adjustment right. So it's just easier, cheaper, and faster to lay down in the rat pee and brace it, get it all on your front, go to town, get it done, get out. Okay.
Why not? I just put a little dab of Loctite.
Because it costs money.
I knew that answer.
You can spend that money if you want.
We
You are
took
the
apart
engineering
one of
solution.
the just the up and down and the release for the scissor lift.
Mhm.
Whole rat's nest right at the top of it. Nice.
Yeah.
Is there-
Well, because it's dark, it's warm,
Yep.
and our wiring is covered in, we use soy-based.
Oh, so
Alright.
you're like the
German car company.
Yeah. And most mice and rats have to eat the wiring because it wears down their teeth, so their teeth don't grow so long. That's why they actually eat the wiring. They don't eat the wiring because they're hungry. They eat the wiring because their teeth are getting too long and it hurts. Most people ask the question by now, how do I know if my inverter is bad? You're going to know your inverter is bad because the person you like the best is the dude with the 3,000 PSI pressure washer that comes in on the weekend and pressure washes everything. You will know when your inverter is bad. There is little to no doubt that you have a bad inverter.
Oh yeah.
Okay, that is, you will find either a burned hole or a very dark blotchy spot where 220 volts and 30 amps moved to ground very quickly and left a trail of how it got there.
Oh yeah.
You will never ever in your lifetime wonder, gee, did I put that on and it didn't need it? Normally too at that point, maybe if you don't even see it, but if you don't get a red light, right? So so those are, that one's actually from my brother. He sent that one to me. He's like, you want one? Sure. I'll take it. Yeah, again.
Just a little soot.
Yeah, it's just, it's so again, you never have to worry about whether or not that thing is, it will let you know it has exited the building. Or I suppose in today's young hip terms, it has yeeted itself right out of there. Yeeted itself. So this one here, if you look kind of closely at terminal 2, you can see where the fire is coming out of the rotary switch from, because the sweeper arms are starting to pit a little bit. And then what happens is the fire sort of licks its way out between the copper and the plastic. It's just right, you can see it in there.
What's
Okay.
this stuff? Is that just like an installation?
Yeah, so that's sometimes we use clear electronics grade silicone. If you use bath and tile silicone on a green board, that silicone's actually very acidic, and it'll actually eat through the green board. So they make pH neutral or pH low electronics grade silicone, because sometimes if we get humidity between the IC chip and the board, it doesn't short itself out, but it shorts itself out enough that it doesn't work. And then you take a hair dryer and you just get the humidity out of it. So rather than becoming a nuisance, we just take the electronics grade, we just sort of spooge it all over wherever we need it to. And then the humidity or the water or whatever can't get in underneath the IC chip and cause the circuit board not to work. Okay. If you notice, there are 3 of these jumpers. Okay. We ordered this switch in from somebody. I don't know who we ordered this switch in from, but only 2 of the jumpers are installed from the manufacturer. You get a little baggie. The little baggie, it's not a dime baggie, but it is a little baggie. You'll get the 3rd jumper. The other cool thing in that little baggie is you get 2 free screws. So the smart ones of you guys will start collecting free screws so you don't have to fish around in the primordial ooze for a free screw. You just go to the truck, figure out where neutral is, put the screw in. The good news is there's only one place to put the screw. These other holes aren't threaded. So if you try to put it in the wrong hole, it just won't start. And then when you finally find the right one, it'll actually go in. Again, you're using one of those little, from the Sears and Roebuck catalog, where they're like 1 inch long and 1 inch in diameter, and you're just back there just tightening it up. It'll stay in for a couple of years, and then it'll work its way out.
Pedal bracket had 3 different positions for that switch. Will they always go back in the same?
Yeah, it'll always go horizontal. It's always horizontal. I cannot tell you why there's 12 different holes in that thing, but they're always 9 and 3.
So when we're replacing the screws, would it behoove us to put a little bit of Loctite on those screws so they don't fall out later?
So the problem is if you do that and then this goes bad, you got to get a die grinder back in there to like grind the head off of that thing. And yeah, they're gonna have. At some point, I think at one point I tried crazy glue. Just something to give it something, right?
What about if you get like a rubber washer, tiny little rubber washer, so it
Or like
mitigates
a
the
lock
vibration?
washer, maybe?
It's not going to happen again for a couple of years, and by then the switch is going to be bad.
Okay.
This switch here is phenomenally expensive. This switch is almost a $300 rotary switch. I think it's because we order it from Italy. It's got to be Italian or something. Oh, look, made in Italy. So we got to pay his ancestors over there reparations for the switch that he makes, right? So it's a fantastically expensive switch. All right, I'm gonna guess too early. What time you got?
2016.
Dang it, man! Every single day, every single day. All right.
2 switches would have been too much.
No, because it is a 220 switch. It does do the 2 legs of power. 2 switches would just sort of be redundant. I will say this: talk about something for the next 27 minutes, so we might as well learn something rather than just talking about chairs. Evidently, we're out of waters because Colin, they're coming down the wrong hallway with waters.
Well, no, there's not over here.
I saw the buffet. Salad, cookies.
I give an explanation, don't I?
You do.
Why are you wearing
That little one. Where's that? You had that little one. It's right there. So falling out. I have to wear a retainer. So, okay. Yeah, I'm gonna get a motor protector. Okay. It's gonna sit like this. Okay, so okay. Technically, this is 2 different machines. These are for Revolutions. This is for the Maverick. Okay, because the Maverick is manual, I don't need as much stuff because you're basically just moving it up and down and in and out, so I don't need stuff. So, on a Revolution, if you notice, the oil filter is not on the solenoid block. The oil filter is sort of attached to the HP unit or the pump. There is because the oil filter housing is not, there's 2 bolts, there's like 2 through bolts with a couple of O-rings because the people who make the pumps don't necessarily put filters on it because they don't know if you want this filter or that filter or the other filter. So when you order in an HPU unit, there will be a whole HPU unit with the block with the filter on it. Most of the time, if you noticed on this filter here, we very nicely placed it facing in towards the tire changer, because why have it facing out where it's easily accessible and readily changeable when we can turn it around 180 degrees and make your life miserable. Okay.
Is that a
That's
regular
engineer's
service
job, isn't it?
component?
Yeah. So on the Revolution and the Maverick, it is in the owner's manual. You are supposed to, I say supposed to, you're supposed to change the fluid and the filter once a year. Okay. The reason for that is because we go from 0 psi to 1600 psi in less than a second. You will notice that, and also the motor gets the fluid very hot. So because we're dealing with heat and we're dealing with pressure, the fluid will start to degrade, and it'll start to turn darker. I've never seen it turn yellow because we don't have the friction modifiers and the clutch material, but it will turn a darker color. Okay. All right.
Extreme cold, extreme hot.
Once a year.
Humidity.
Just once a year.
Once a year. Once a year. Once a year.
Usually different viscosities for like north and south.
ATF.
Oh, no, where it's right, it's all ITS.
Dextron 3. Triple filtered. So the cooler part is the tank. The tank is nice and clear, so you can see how much fluid is in the tank. At the top of the tank, there is a sticker. We usually tell you to only fill it up to the bottom of said sticker, because fluid, as it heats up, expands. So if you fill it up past the sticker, it's just going to spew out the fill hole, and then you're going to have nice strawberry shake mix in places you don't really want a strawberry shake mix. To make it even more fun, the tank that is on the Revolution or the Maverick, there is a hole for a drain cock, but we didn't bother to put it in there. It's just molded over. So there is no way to drain the tank. So for you guys who work in shops, they have a fluid extractor. Just put your fluid extractor in. What I would do first is I would take all of my pistons and collapse all of my pistons just to put as much fluid back into the tank as I could. You do not have to flush the system. It is not a flush. It is just a drain and refill. So whatever you take out of the tank is whatever you take out of the tank. And you're going to put new fluid into the bottom of the sticker, and you're going to get, I don't know, 90% of the old fluid out. You might have 10% in the lines and that. It's fine. It's just a once a year thing. We're more concerned about particulates than anything else. Okay, so if you don't get it once a year, I know that there are plenty of Revolutions in my area where they were 5 years old and I had never changed the fluid because I was too busy putting out fires. I couldn't do regularly scheduled maintenance. Never call it preventative, because the day after preventative maintenance, something's going to break. So you call it scheduled maintenance. So the day after something scheduled maintenance breaks, you're like, well, I just did the scheduled maintenance. I didn't say it was going to prevent anything. We're just doing maintenance. Okay, so scheduled maintenance, not preventative maintenance, because it will make you look stupid. So the other thing for those of you guys who are thinking, man, that tank is only held on with a band clamp, I'm going to take the band clamp off and take the whole tank and dump it upside down. The suction line is hard plastic, and when you try to take the tank off, you will break the suction line flush at the top of the pump. And at that point, you have just bought an HPU unit, or Hunter has because it's under warranty. So, don't do that. Don't ask me how I know that either. So, just put in your fluid exchanger, fluid it out. Again, on the Maverick, we made it simpler, and we are literally using a Napa Gold filter right here. I've seen Wix and I've seen Napa. Evidently, we just whatever's 3 cents cheaper that day, we're going to buy 1,000 of them, and then we're going to use them, and then we'll just buy some more. The other ones on the Revolution, it is a weird, funky little white filter that costs about $80 through Hunter. That's great because it used to cost $300 through Hunter. That white filter will usually leak on the very end that you can't see. There's like a little bolt head, and I'm not really sure what it does. Between the bolt head and the actual filter itself, it'll usually start to just drip out of there for some reason. You just replace the filter. You can get to it. It's sort of sticking out the back of it, but not really. Again, this filter here is much easier to get to because it's just a regular filter. Okay. As far as valve bodies go, there's only one valve body for the Maverick because it's newer, so we only have the one. On Revolutions, it depends on whether or not you have a pneumatic cylinder or you have a hydraulic cylinder from the factory. So for the first, from 2013 up until about 2021, you had pneumatic spindles. Starting somewhere around 2021, we started to do hydraulic spindles from the factory, so we had to come out with a different valve body because we had to do different things with hydraulics. If you have a Revolution tire changer from circa 2021 until today that has a pneumatic spindle on it, you have to upgrade it to a hydraulic spindle. So you're going to get what they call as a daughter manifold, and the daughter manifold will just attach itself to the regular pneumatic manifold, and it turns it into a hydraulic spindle Revolution. Okay. Basically, what we do is we borrow one of these two hoses. So one of these two hoses goes over to here. We have a short little jumper hose because I still have to get fluid back to the original spot. So I move a hose, I add a hose, and then on the bottom, the hose comes out and goes to the spindle. Okay. Over here, because we already knew we were switching to all hydraulic spindles, we just added, basically now this is this much longer because the daughter manifold is now made into one big giant manifold. Okay. In 1.8 software, there is a new setup question. Do you have pneumatic, a hydraulic, or a hydraulic retrofit? This is considered a hydraulic retrofit because these two valves on the hydraulic retrofit are backwards from the hydraulic valves from the factory. I don't know. We try. I don't know. The nut, there's a small nut and a bigger nut. The nuts are there. The bigger nut is here for heat dissipation because this solenoid has to remain active the whole time the spindle is clamped. So we don't want this to get, so we're making a magnetic field and the valve is being pulled. So we have this little nut here to act like an old a Vega, not a Vega, but a Corvair, those air-cooled engines. All right, we're just trying to get a little more air on it. Okay, so the ones with the small nuts, this is like my fill valve, and then the ones with the big nuts are my hold. Okay, so the small one opens, fills the cylinder up, the cylinder pulls down, and then these turn off. That one turns on to keep the fluid captured. Because I only have one hose going to my hydraulic spindle. So on a hydraulic spindle, there's a giant spring on the bottom that pushes back up, and it has to be like an F100 spring from like 1986 because we have to be able to expel the fluid out of the spindle so that the shaft comes back up. Okay. For that reason, you guys will notice on a fully hydraulic one, again, because all of the return lines share a common port. Sometimes when you move an arm up and down and the spindle is not engaged or locked, the spindle will sort of float, sort of like an old Oldsmobile going down the highway. It just sort of bobbles up and down. Right? You can just see the guy in there. He's in the velour. He's just driving. Best thing in the world. They drove so good. But that's because when the negative pressure is moving by, it's pulling some of the fluid out of the spindle because, again, it's just one hose and it just gets sucked out. Okay. When you stop moving the arm up and down, the spindle will pop all the way back up because it builds up enough pressure, and then we get to where we're going. Okay. When you have a pneumatic spindle, there are no more replaceable parts. There's nothing you can do. You buy a kit. The kit has to ship by truck because it weighs over 125 pounds. And even though UPS makes a stupid amount of money, they're girly men and they don't want to lift up something that heavy. So you're going to get it on a pallet. It comes with everything you need. It comes with the spindle. It comes with all of the hoses. It comes with the daughter manifold. It comes with a new wiring harness, because the new wiring harness off of the power outs board, we don't have to engage the one solenoid that used to put air to the pneumatic spindle. Now you don't remove that solenoid because that solenoid is blocking off an air passage. And we're saving money. Rather than giving you a blanking cap, we're like, well, they're never going to use that again, so we'll just leave it there and not plug it in. Kidneys, right? Okay. So it comes with all the hoses. It comes with a new software drive. It will come with a program drive. You don't get a new data drive because you don't need a new data, but you will get a new program drive. So you get everything needs one nice kit. I'm going to apologize right now. There's a video. You'll have to look at me for an hour. I apologize. But there's a video in case you need to upgrade one. There's a video out there. It's somewhere in the universe on the main page. I did it with all hand tools. I think you get under warranty. I think you get paid $2.50. It's not bad. You can beat $2.50. I did it with hand tools. And unlike you guys, we don't do it like where all the hand tools are laid out and you do it 7 times. I had no hand tools laid out and I did it the first time and we're like, oh, that looks like a good time. We'll just put that in the book. So we're not trying to cheat you out of money in warranty.
I thought we didn't get paid for warranty work.
We still have to put a time down,
Okay.
right? There still needs to be a time.
Yeah. You have to
Well,
say how long
theoretically, the part will be under warranty, so we have to give you a labor op in case one day you'll have to do it as central service call. We have to give you something because you have to put it in there. Right? So,
Isn't there some kind of labor warranty within there, like 6 months labor warranty?
Yeah. Yeah. So I mean that might happen. Yeah. So we have to give you a basis time so that you can either multiply it by 50% or 100% or whatever you're going to do. Please don't tell me. I don't want to know. But we have to give you a basis time so that you can come up with customer pay. But most of the warranty times they're very generous. They're not like 3/10 and 2/10 and stuff like that.
I know you gotta
Again,
change this motor, but
I'm sorry.
Citrus by fives.
Yeah. So the other thing is in the labor time guide, we probably only have labor ops for about 30% of every operation you're ever going to do. We don't have a labor op for like replacing a hose. At that point, there's a miscellaneous M1995. You just throw that up there, half hour or whatever, say what you did. It's easy enough. Okay, back to this. Valve bodies, solenoid blocks. Okay, so big thing here, P stands for pressure or pump, T stands for tank, right? So I'm getting pressure in from my pump. It goes through all the valves. It comes out. The T goes to the tank. Okay. It took me, and I must admit, it took me 15 years too long to understand this, but because I'm a car guy. Car guys, the oil filter's on the pressure side. On these units here, the oil filter's on the return side. And for years, I'm talking years, and I'm ashamed to admit it, I couldn't figure that out until I realized that thing's not going to hold 1600 PSI. Like one day it finally clicked. Like, idiot, it's built for 40 PSI or 80, not 1600. So as we're filtering it at some point, we're just filtering it when it goes back into the tank rather than as it comes out of the tank. So as the fluid returns, it does go through a filter, and that way you're getting clean filter through the pump, through the gear rotor through and through the solenoids and all that. So because on the return side it's not 1600 psi, right? This is like it hit me in the forehead one day. I'm like, oh, I'm so glad that finally clicked because it just took me forever. So what we have here, we have lots of valves. Okay, you can only check these valves and these valves with the solenoid checker because these valves are either 0 or 100. They're either fully closed or fully open. Okay, this is a single acting valve because there's only one solenoid on it. This is a double acting valve because there's two solenoids on it, which means if I wanted to look at this one, I'm going to say, so this one says, let me see if I can read, tool hook down, tool hook up, right? So if I want tool hook down, I initiate the solenoid on the inside and it pulls the valve this way. If I'm not doing anything with the tool hook, it centers itself out and then nothing has pressure. If I want to go tool hook up, then I'm going to initiate this solenoid and it's going to pull the valve out rather than pulling the valve in. So I have up, so this, everything is an up and a down or an in and an out. If it's vertical, it's an up and a down. If it's horizontal, it's an in and out. But it's always the same valve moving the piston because it's a dual acting piston, right? So it has to go both ways. Okay. All right. So what we have on the ends, these two little valves here are my pulse width modulated controls. So that acts as your gas pedal, right? When you move something a little, it moves a little. When you move something a lot, it moves a lot. So what happens is we have to open up two valves. We have to open up a pulse width modulated, and then we have to open up what it's moving, okay? So what happens is if you're trying to move two arms on the same bank at once, it has to split the fluid because this pulse width modulated does the top and this one does the bottom. So if I'm trying to move two arms, I only get half the fluid because the pulse width modulator is only letting through so much fluid at a time. So that's why when you do tools clear, everything moves slow until something hits a stop and then the other two start taking off and the second one hits a stop. And by then the third one is shooting up like an Elon Musk rocket trying to go to wherever it's going to because we're getting all of the CFM at that point, right? Because I only have so much CFM coming through the little solenoid.
Those are just sleeve solenoids. They just go over there's a metal stem inside of it.
Yes, so that's why I have this. So if you ever come up to a solenoid and you can turn it, that solenoid is loose and it's not going to perform as much of a mechanical, a magnetic field as it should. So you never want to be able to twist a solenoid, okay? So I'm going to take this, and these nuts are 3/4 inch nuts, but they're very thin, and trying to get a wrench on it stinks. Be careful. Become that tourist. Take lots of pictures. You don't necessarily have to unplug these, but if you're going to take more than one of these off, you don't want to put them on this way because then the valve's going to go backwards, okay? So you have a solenoid. Excuse me. You have a what's a solenoid? Coil solenoid. Coil. Fine. Magnetic coil. Fine. The magnetic coil, and then you have
Isolator.
it's an isolator, but we had to come up with a really cool term, so we call it a ferrite core. And ferrite is iron. So it's an iron ring because what we have to do is we have to stop the coil, just for you today. We have to keep the magnetic induction to here. Otherwise, if we don't have this coil is going to affect that coil is going to affect this coil. So because we're an engineering company, we can't just say it's an iron sleeve. We have to come up with ferrite core because by golly, if that don't sound engineering to me, nothing's ever going to sound engineering. And again, because that piece of iron is there, it stops the magnet. That's how I can move it either this way or that way because of this. Okay. If you notice, there's a steel end, and then there's the actual end where you can actually see the coil. The coil end that's open always faces down the stem. Then you put your space or your ferrite core in. You take the outer one and you do the same thing. You put the outer one on so that when you tighten it, you're tightening it against the metal because if you actually tighten it against the coil, you could crack the coil or smush the coil, and we don't want that happening. So when you put the nut on, you're basically turning the nut, and it's basically like, can I twist it? Yep. Keep tightening. Can I twist it? Nope. You know. Sure.
Same concept.
Sure. We'll go with that.
Thread it into that valve body.
Yes. So
You
that's
unthread that while it's pressurized. It's going to shoot out of there at Mach 30.
just for about a half a second. You'll be fine.
You'll see the fluid coming first.
Yeah. So that's why in one of my emails I told you need to get an extra deep 7/8 and an extra deep 1 inch. A lot of people think that they can put their universal oxygen sensor tool on here, but by the time you get in there and you see how little space you have, usually you buy it off of Amazon. It's usually a Sunex.
Sonex makes a
Right.
kit for about $100.
Yeah.
But if you
But
buy
it's
the
like-
individual sockets, they're
yeah.
$25.
It's like a 4-inch throw on the, because you need it long
It's a
enough
5.
to. Is it? You need it long enough to go over the stem at that point. Okay. Because especially if you're trying to get this one out, you're bordered on either side, and you don't want to take 3 of them out. You're just trying to get to the one. So Craftsman makes extra deep too. I never found them. I never even found them on Amazon. Okay. So you only need a 7/8 inch here. You need a 1 inch on our racks. Our racks use a bigger solenoid because they have to move more fluid. So we need a bigger solenoid and coil assembly to move 3.5 gallons per minute. So it's still 24 volts. It's just it has to be bigger because I have to move. Yeah. So they work. So these are pulse width modulated because I have a $15 solenoid checker. It can't blink that fast because you're blinking multiple times a second and the thing just can't do it. So it's either going to pick up the and if this is working, odds are. Another thing that we learned the hard way, and these two probably know this already. If you unplug this solenoid and check the AC voltage, you're only going to get about 7 volts because there's no resistance. If you check this plugged in and you sort of probe underneath it, you will get the 24 volts AC that you're supposed to get because it's actually energizing the field and there's resistance to it, so we put all the voltage to it. We're lazy. I don't know why it's only 7 volts when it's unplugged. It's just 7 volts. I don't know. It's always been a mystery. It's always been a mystery. Did he say AC or DC?
I would think it's easy.
VAC? What's that say? What's that say?
DC.
DC, okay. These are DC. The ones on the rack are AC. Okay. So again, 7/8 is DC, 1 inch is AC. But I know the ones on the rack are AC, and I always just transfer that. So it's fine. But still, again, you won't measure the right voltage if you try to just deadhead you got to have it plugged into something. I guess it just needs to see the load. Okay. All right. So we have pulse width modulated stuff. We have regular valves that are either open or closed. These two guys here are both. These are both pulse width modulated and directional. One of these does the spindle. One of these does the tilting. But because we're moving more fluid, and if we're trying to pick up that 19.5, we got to have a little more oomph when we're tilting. So again, we can't use the solenoid checker here, but at least these two valves are the same. So if you need to check it, you can just swap it, and at least you can do some preliminary diagnosis before you sell them a whole new Revolution tire changer. Okay, at least you gave it a shot, right? I gave it a try. I didn't figure it out, so buy a new one.
Other than the solenoid, the valve bodies ever wear out or hit or anything like that?
No. No. Matter of factly, it was for a really, really, really long time. We wouldn't even sell you a whole thing. You had to buy individual pieces, parts, because in our minds, this is just solid aluminum, and there's nothing to wear out. Again, the valves can stick, but the block itself is just a block. Again, we're not dealing with vibrations, RPMs, or a lot of heat, right? It's just sitting there, Okay. This one is the only one on a pneumatic solenoid that has all the cool little stickers on it. When we went to hydraulics, we actually started to punch the numbers into the valve, so at least you know what valve you're looking for, okay? The older ones, we hated you a lot, and it's just smooth aluminum everywhere. On to this one, because I only have a limited amount of time, and we're just talking about valve bodies. These two guys on the end are your pulse width modulated. So this pulse width modulated one does these four. This pulse width modulated one does these two. Okay. There are two bolts right here that'll have the two bolts have the O-rings on it, because the O-rings here are, well, the O-rings go in for the fluid. The two bolts just go through to their sandwich O-rings, because someone else makes the pump. It's probably a Septima or a Bonani pump, just like the other one. We make the valve body, so we had to figure out a neat way to make this work. So at least we incorporated the oil filter now into the valve body. One of these, and I think this one, since it's under here, I'm going to say this one. When you have to check to see if an arm is going up and down right, you're supposed to check the arm against pump pressure. How much pressure does it take to move the arm up and down to see if your high HDPE bearings are tight enough or too loose, because we don't have a screen, right? So you're going to look, and the magic number is between 500 and 800 psi, which seems to be quite a healthy range because something about when you're extending it or you're retracting it, it's different pressures. I guess it's easier to retract it than it is to extend it. I don't know, but we give you a 300-pound range. It's a 1,600-pound motor, so half of the pressure is just moving it without even any resistance on it. We're just trying to make, because if you don't have enough on it, then the arms are loose and then they're banging and clanging, and then we're going to scratch wheels and stuff like that. So we have to make them fairly tight so that they stay tight, so that we don't scratch anything. Okay. So these are all, you can check these valves with the valve checker, but these are your pulse width modulated. Because that's only a 2 horsepower pump and not a 3, we don't have the giant. And that one there, we have a wheel lift, so that doesn't tilt, right? So we got away with less parts. So I don't know if we're saving money or not. It's only like 22 grand, right? We're barely breaking even, I think, probably by the time we sell that thing. So I'll just keep smiling. All right. Just lots of, again, dual acting valves. Also DC, which makes sense because the other one's DC. Again, racks are AC. What time is it?
12:03.
Okay, fine. And then again, once a year, you have to suck the fluid out of the tank, replace the filter. Just as we're just worried about contaminants. Okay. That one's, there's a cover that's normally on that one, but we took the cover off because we know service people love to look at stuff, so we made it easier to see. There is a black cover to keep the honest people from losing their eye from hydraulic fluid shooting into it. Looking at you. So, yeah. So.
I got a 23rd hydraulic.
I'm sure you do. All right.